You felt it. That moment when a project you loved becomes a project you dread. In the first week, you were a wizard. You added features in hours. But now, 6 months later, adding a single button feels like performing open heart surgery. You touch one line of code and something unrelated breaks 3 folders away. You've hit the wall, and that wall is made of every quick fix and we'll clean this up later decision you ever made. Most people think they have a coding problem. They don't. They have an architecture problem. In this video, we're going to peel back the curtain on how professional systems are actually designed to survive the test of time. There is a massive difference between programming and software engineering. Programming is the act of telling a computer what to do. Engineering is the art of designing a system so that 10 other people can tell the computer what to do without breaking each other's work. Imagine building a small wooden shed in your backyard. You don't need a blueprint. You just buy some wood and start nailing. That's a script or a tiny app. But if you try to build a 50-story skyscraper using the same just start nailing method, it will collapse before you hit the third floor. Architecture is the blueprint that keeps the skyscraper standing when the wind blows, or in our case, when the traffic spikes. Let's talk about the monolith. In the early days of any SaaS, the monolith is your best friend. It means your entire application, the database logic, the user interface, the payment processing, is all in one single code base. It's simple to deploy and fast to develop, but as the golem grows, it gets heavy. If the golem's left toe gets an infection, the entire golem gets a fever. In software terms, if your export to PDF function has a memory leak, it can crash your entire server, taking down the login page and the payment gateway with it. This is tight coupling. Everything is glued together. When you want to upgrade one part, you have to risk the whole. Now, imagine a different approach. Microservices. Instead of one giant golem, you have a fleet of small, specialized ships. One ship handles users. Another handles payments. Another handles notifications. If the notification ship breaks, the payment ship doesn't even notice. It keeps flying. This is called fault tolerance. But there is a catch. In a monolith, the brain just tells the hand to move. In microservices, the user ship has to send a radio message to the payment ship. This introduces latency and complexity. You don't start with microservices on day one. You evolve into them. Knowing when to break the golem into ships is the mark of a senior architect. Every time you choose a shortcut over a solid design, you are taking out a loan. This is technical debt. Like any loan, it comes with interest. The interest is the extra time it takes you to fix bugs later. If you have 0% technical debt, you're moving too slowly and your business will die. If you have 100% technical debt, your code will become legacy in a month and you'll never be able to ship a new feature again. Architecture is the art of balancing that scale. It's about being intentional. It's about choosing which problems you want to have tomorrow. In this series, we aren't just going to look at code snippets. We are going to look at the big picture. We will learn how to deploy these systems, how to scale them, and how to turn them into a profitable SaaS. But before we can build a city, we need to know how the inhabitants talk to each other. How does the user ship tell the payment ship that someone just bought a subscription? In the next video, we're entering the world of APIs and the request/response cycle. We'll see why the API restaurant is the most important metaphor in web development. I'll see you in the next one.